Welcome to this explainer. Today, we're taking something massive, totally abstract, and almost entirely mathematical, and we're going to translate it into a visceral, physical reality. You know, we hear the word trillion all the time in the news, but do we actually know what it looks like? Well, we're going hands-on today to uncover the literal, physical architecture of $1 trillion.
Just take a second and look at those zeros. Go ahead and count them. 12 of them. 1 trillion. It rolls off the tongue so easily, right? But actually writing out a million reveals the sheer intimidating weight of the math we're dealing with today.
All right, section 1, the $1 trillion problem. So here's the thing. We hear trillions so often regarding government budgets and corporate valuations that we've kind of lost our sensitivity to it. But the truth is, evolution just didn't prepare our human brains to intuitively grasp a number this exponentially huge. To fix this, we're going to build a mental model using a physical anchor you already know, the $100 bill. Get ready because we're aiming for a profound aha moment here. Okay, let's dive into this. To reach exactly $1 trillion using $100 bills, we need exactly 10 billion individual bills, 10 billion of them. For some context here, a single bill is incredibly thin and weighs just about 1 gram. I want you to keep that single 1 gram piece of paper in your mind because we are about to multiply it 10 billion times.
Moving on to section 2, from briefcase to warehouse. To really understand a trillion, we actually have to start with a million. $1 million in hundreds makes a stack about 4 to 5 feet high, and that fits easily into a standard briefcase. You could literally walk right down the street with it. But $1 trillion? That requires 10,000 standard shrink-wrapped pallets of cash. Those pallets would completely cover an entire football field. Think about that visual difference. A single backpack you can carry versus an entire football field blanketed in thousands of massive pallets.
Let's walk through the exponential cliffs of these multipliers, because it is honestly mind-blowing. Step 1 is our $1 million briefcase. Simple enough. For step 2, $1 billion, you need about 10 pallets. If you stacked $1 billion straight up into the air, it would be 0.68 miles high. That's already taller than many of the world's tallest skyscrapers. And remember, $1 billion is just a tiny, tiny fraction of our goal. To reach step 3, a full $1 trillion, we have to take that skyscraper-sized stack of $1 billion and multiply it by 1,000 times.
Section 3, stacking bills into space.
Now, what's really interesting about this slide is what happens if we take that football field of pallets and stack all those bills straight up into the sky. Low Earth orbit is an absolute monumental human achievement, with the International Space Station orbiting roughly 250 miles above our heads. But a single, flat stack of $1 trillion, that reaches a staggering 679 miles high. Our stack completely dwarfs the International Space Station, extending more than 2.7 times further out into the vacuum of space. No way, right?
Section 4, cargo ships and pools.
So we've looked at these dizzying heights, but what about crushing physical mass? Today we mostly interact with bank balances as invisible, weightless digits on a screen. But physical reality paints a much heavier picture. Multiplied 10 billion times, that little 1 gram bill becomes catastrophic. Ready for this? $1 trillion weighs approximately 10,000 metric tons. That is 22 million pounds of paper? To put that into perspective, that's the equivalent weight of up to 10,000 average cars stacked on top of each other. You would need several large oceanic cargo ships just to transport the raw weight of this cash.
And this brilliantly illustrates the sheer spatial volume we're dealing with. If you didn't stack it perfectly to the edge of space, but just poured it all out, you would need to completely fill 4 to 4.5 Olympic-sized swimming pools to the very brim with pure currency. That is roughly 398,000 cubic feet of solid money. Imagine diving into an Olympic pool and it's not water, it's perfectly packed $100 bills, and then realizing there are 3 more pools exactly like it just to equal 1 trillion.
Let's move to section 5, the global economic scale, and see how this builds.
Let's zoom out from physical space directly into the scale of macroeconomics. $1 trillion isn't just a giant pile of paper. It represents roughly 3% of the entire projected United States economy. Globally, it mirrors or even exceeds the entire annual economic output of major highly developed nations. We're talking about economies on the scale of Italy, Canada, or Brazil. Literally, $1 trillion equals everything those nations produce in a whole year.
When we look at the figures objectively,
$1 trillion vastly exceeds most typical annual federal program budgets, and it outstrips the market capitalization of the vast majority of major corporations. Whether you're analyzing government deficits or tracking corporate power, we just have to impartially recognize that this figure represents a scale that heavily overshadows almost all individual human enterprises. It's a number reserved for the absolute peak of global financial tracking.
Section 6. Why Money Went Digital.
We've visualized the mind-bending physical absurdity of these numbers today. So the crucial point is that physically moving or storing that much cash would be logistically insane. We cannot maneuver thousands of pallets across football fields or load cargo ships with 22 million pounds of paper every single time nations trade or governments balance a budget. The scale of human wealth has simply outgrown the physical realm, and that is exactly why modern finance relies almost exclusively on digital transfers.
I want to leave you all with a final, provocative thought. If every major transaction, government budget, or corporate merger actually required mobilizing armadas of cargo ships, filling Olympic pools with paper, and building paper towers miles past the space station, how fast would our economy actually move? The sheer friction of physical reality would literally bring the world to a standstill. So the next time you hear the word trillion, don't just think of a 1 with 12 zeros. Think of the rockets, the cargo ships, and the stadiums of paper that make up the invisible digital world we interact with every single day. Thanks for joining me on this explainer, and keep questioning the scale of the world around you.